Good afternoon, everyone. My name is Karl Linden, and I'm chair of the Civil, Environmental, and Architectural Engineering Department in CU Boulder's College of Engineering and Applied Science. Thank you for joining us today to learn about our new Master of Science in Sustainable Engineering. This is a 9-month, full-time, in-person professional master's program designed for engineers and technically minded professionals who want to work at the intersection of engineering design, sustainability, and real-world policy and economic decision-making. I'll spend the next few minutes explaining why we created this program, why we believe now is the right moment, and what distinguishes this degree at CU Boulder. Then we'll be happy to take some questions. Let me begin with the broader context. The sustainability challenges we face today, whether related to energy systems, water resources, infrastructure resilience, or the built environment, are no longer peripheral to engineering practice. They are central. What has become increasingly clear is that these challenges are systems problems. Technical performance still matters deeply, but solutions also depend on economic feasibility, regulatory constraints, institutional decision making, and the needs of communities affected by engineering projects. We created this program around a guiding principle of sustainability by design, or the idea that sustainability should be embedded into engineering decisions from the outset, rather than addressed after the fact. That perspective has shaped every aspect of this degree, from curriculum structure to how students work together across disciplines. So, why an MS in sustainable engineering, and why now? Well, across industry, government, and the nonprofit sector, engineers are being asked to do more than design systems that work technically. They're being asked to design systems that are resilient, resource efficient, and responsive to social and environmental constraints. That requires a broader skill set than traditional engineering programs typically provide. For example, designing renewable energy systems means understanding grid dynamics, but also financing mechanisms and regulatory frameworks. Building resilient infrastructure requires technical analysis, also requires life cycle evaluation and engagement with the communities that depend on those systems. Reducing emissions in manufacturing involves engineering redesign, supply chain considerations, and carbon accounting. There's a strong demand for professionals who can work across these boundaries. At the same time, relatively few programs explicitly prepare engineers for this kind of work. That gap is what motivated us to build this degree. The MS in Sustainable Engineering is a 9-month program that runs from fall through spring. For some students, particularly those who want to strengthen or refresh specific quantitative or computational skills, we also offer a Jumpstart program in the summer. This provides preparation in tools such as Excel and Python, along with skills that support effective technical practice, including teamwork, project organization, and communication in technical settings. The academic year itself is structured in 2 parts. First is an integrated core in the fall, and then we have engineering electives and a capstone in the spring. The structure is intentionally streamlined, focused, and intensive, and designed for students who want to return to professional practice with an expanded technical and interdisciplinary capabilities. The fall semester is where the program's distinctive approach becomes apparent. During this period, students in sustainable engineering and students in the companion sustainable business take shared curriculum together. You're in the same classroom working on the same problems. And this integration is not incidental, it is a central feature of the program. The core is organized into 2 halves. Term A focuses on measuring and assessing sustainability systems, understanding environmental processes, data analysis, and accounting frameworks. Term B shifts toward leading change, policy, management, and the design of sustainable technologies and systems. Each term includes courses taught by faculty from engineering, from business, and related disciplines. In addition, we schedule integration days where faculty and students work together on applied projects that require multiple perspectives. The goal is to help you learn how to collaborate effectively across disciplines because that is how sustainability work actually happens in practice. In the spring, you shift focus to engineering depth. You'll select electives aligned with your interests, such as sustainable engineering design, embodied carbon in buildings, energy systems, hazards and resilience, global development, water and sanitation, or other topics. The program concludes with an integrated capstone project, completed collaboratively with students in the Sustainable Business cohort. These are applied projects informed by real organizational needs, and they involve industry or public sector partners. They're designed to reflect the technical, economic, and institutional constraints you will encounter in professional practice. A question we often receive is how this degree differs from the MS in Sustainable Business. The two programs share the integrated core in the fall, and after that, they diverge. Students in the Sustainable Engineering MS have bachelor's degrees in engineering or relevant STEM fields and focus on designing and implementing technical systems, including energy, infrastructure, materials, and buildings, while integrating business and policy considerations. Students in Sustainable Business MS focus more on organizational strategy, ESG, finance, and managing sustainability within firms. This degree does not require a background in engineering or STEM and is less technical in nature compared to the engineering degree. The programs are complementary. In practice, graduates from both often work in the same organizations. They address the same challenges, but from different professional perspectives. Graduates of this program are prepared for a range of roles across energy, infrastructure, water, manufacturing, and the built environment. The skills you develop include life cycle assessment and evaluation of design alternatives, carbon and greenhouse gas accounting, modeling and visualization of sustainability data, applying policy and regulatory frameworks to engineering decisions, and leading interdisciplinary teams and engaging stakeholders. These skills enable engineers to move projects forward, to design solutions that are not only technically sound but also implementable. The MS in Sustainable Engineering is intended for engineers and technically minded professionals who want to broaden their approach to engineering design. That includes recent graduates, including those considering a fifth-year master's pathway, practicing engineers seeking deeper engagement with sustainability challenges, professionals with strong technical backgrounds who want better integration with business, policy, and data analysis, and students motivated to address urgent sustainability challenges with tools grounded in engineering practice. Applicants should hold a bachelor's degree in engineering or a related STEM field and demonstrate readiness for advanced technical study. We review transcripts, a resume or CV, a personal statement, and letters of recommendation. The GRE scores are optional. The application deadline is April 15th, 2026, and applying early is strongly encouraged. Before we move to questions, let me say a brief word about why CU Boulder. We developed this program because we saw a clear gap between the sustainability challenges engineers are being asked to address and the way engineers are traditionally trained. CU Boulder has deep expertise in sustainable energy systems and water and sanitation, resilient infrastructure, buildings and materials. Just as importantly, we have the institutional capacity to integrate that technical expertise with business, policy, and data analysis in a coherent and deliberate way. So, if you're looking for a program that is technically rigorous, systems oriented, and grounded in how sustainability work actually happens, this is what we've designed. Thank you for your time, and I'm happy to take some questions. We have a few questions here that I'll address. First is, how is this program different from environmental engineering? Well, environmental engineering focuses more narrowly on areas like water and wastewater treatment and air quality and remediation. And this program specifically takes a broader systems perspective, including energy, water infrastructure, buildings, and materials, and explicitly integrates business and policy considerations throughout the program. Can students work while enrolled? This is a full-time residential program that's quite intensive. The integrated projects and team-based work require significant engagement, and students will need to focus fully on the program during the 9 months. Another question is, what if my undergraduate degree isn't in engineering? Students with strong STEM backgrounds, including physics, chemistry, math, and environmental science, may also be well prepared. And we look carefully at quantitative preparation and encourage prospective applicants to speak with our advising team. Question is, what are capstone projects like? The capstone programs are applied team-based projects that reflect real sustainability challenges that organizations will be facing. The types of problems we work on are provided by our industry partners who also serve as project mentors. The emphasis is on analysis, design, and implementation within realistic constraints. Could this lead to a PhD? This is designed as a professional master's program specifically, that is a terminal master's degree. That said, strong students sometimes discover research interests during the program and explore doctoral pathways separately with their advisors. And lastly, what kind of jobs do graduates pursue? After graduation, students would typically pursue roles that combine technical responsibility with leadership, including energy systems engineering, resilience and infrastructure roles, life cycle and carbon analysis, building performance, and sustainability focused engineering positions across many sectors. That's all the questions we have. On the screen, you'll see a QR code to learn more, and certainly feel free to reach out to us via email to contact a program advisor at the email listed on the screen. We look forward to hearing your further questions and talking to you soon about our program. Thank you.